back to this. Alrighty, what are we doing today? So we are going to be, covering the oxidizing capacity of bleach. I'm going to kind of walk through what you would have done from the lab, and I'll give you each some data. So you'll each have be assigned a certain amount of data, and once you're assigned the data, then you'll be able to essentially crunch the numbers. So I think there's some use from this because it'll at least go from a classroom perspective, get you used to doing the math that's necessary for this type of experiment. So just from an understanding, even from a biological assay, if you think about it from the assays that run for all of these, these screens that they're doing to determine who has COVID and the like, they always have to go through and do these types of standardizations, and a lot of they're not really exactly this type titration based experiment, but they're similar from the perspective that you're getting a dose response curve. So you add a little more concentration and you're looking for the response in the assay. But the solutions that they use are all standardized beforehand. So they do standardization curves and do some of the parts, which is going to be similar to this. So that's part one. We'll talk about standardizing the sodium thiosulfate solution, right? And then we're going to move on to part two. Once we have that standardized sodium thiosulfate solution, we can take this unknown concentration of sodium hypochlorite, which is just bleach, and we're going to use this standard sodium thiosulfate solution that we did in part one to determine what the concentration of this sodium hypochlorite solution is. And both of these experiments rely on the use of iodometric titrations. All that means is that we're using, we're observing the reaction, right, of I2 going to I1, two iodides basically, and we're observing this using some type of starch-based reaction identifier. Starch, when it's complex with iodine, forms this deep blue color. So we're looking for color changes as we're interconverting between the two different oxidation states of I2 and I minus. So in part one, we're going to have the, what we would have done is we'd have the concentration of the sodium thiosulfate is precisely determined by a process called iodometric titration. And we would have started with an approximate concentration. So we would have approximately, it's approximately 0.1 molar, for example, but you want to figure out exactly what it is. And the way we would do this is in the first step, right? We're going to use potassium iodate. And what you're able to do is you take a balance and you're able to weigh out, in a flask, you weigh out a specific quantity of potassium iodate. And what this allows you to do is that you have a solution that you're starting with, and right in the solution, if you think about the solution that exists with sodium thiosulfate, right, we have the ability of water molecules to evaporate away, and oops, that's a really bad water, H2O there. Our water molecules can evaporate away, and we see changes in concentrations occurring based on just evaporation and the like. Whereas when you weigh something out, you have a known quantity. It's not evaporating. It's the quantity is what you weigh, and you can calculate how many moles there are. And so we take this potassium iodate, we're able to weigh out a known quantity, and we're going to react it with potassium iodide in an acidic environment to form this triiodide ion, I3 minus. It's a polyanion with 3 iodine atoms linked covalently, and this just creates this dark brown solution, right? So the reaction we're talking about here, right? And we're ignoring, right? There's a potassium ion here. There's another, oops. There's another potassium ion here. Right? That's counter ion, and this is probably there's a chloride counter ion floating around for each of the protons. Right? So there are, these are all spectator ions. They're not really participating in the reaction, so we're ignoring them. But you see the reaction where we're taking the iodide, taking the iodate ion and converting by an oxidation reaction the iodides to, for an via oxidation reaction to the I3 minus ion and water. Right. The next step we would have taken the triiodide that's produced, right, this 3i3 minus, and we're going to react it with the thiosulfate ion. Right, we're going to react it with the thiosulfate ion, and you can see this reaction takes and converts the sulfur that's in the reaction mixture here from its +2 oxidation state to a +2.5 oxidation state. So there's an oxidation reaction going on for the sulfur, and then the triiodide is reduced back to the iodide ions. So this particular reaction is difficult to monitor from the perspective that this brown color, we would have been using UVs, and the brown color isn't easy to visualize. So what we would be looking at is a starch indicator, and this starch indicator starts off as a dark blue color, and once converted back to the iodine is converted to an I minus, we actually form a clear solution. We'll talk a little bit more about that in the next slide. All right. Oh, maybe 2 slides. All right. So since we know precisely how much potassium iodide is used in the titration with the sodium thiosulfate, you can calculate the concentration of the sodium thiosulfate. Right. So here's the 2 different reactions from the previous slide, right, where we take the iodate, react it with iodide in the presence of acid to give our triiodide. That triiodide then reacts with that thiosulfate to form the newly oxidized compound as a product, and returns and gives us some more iodine back. And you can see we obviously have, from this equation, we can see for every 1 iodate ion we add to the reaction mixture, we generate 3 triiodide ions out, right? So that's our multimole equality. And then for every triiodide that we use in the second reaction, we consume 2 thiosulfate ions. So you can see how you can easily convert from the number of iodate ions to the number of thiosulfate ions through this link of the triiodides, right? Right, and then you could do that by simply turning both of these equalities into conversion factors, right? So you can see we start with a certain number of moles of iodate. We multiply that by our conversion factor, right? This conversion factor here of 3 triiodides for every iodate comes from right there. And then we multiply that, so this allows us to cancel out the periodate ions. And we multiply that by the next conversion factor, which is 2 thiosulfates for every iodide, which allows us to cancel out iodide. So you can see by having a known quantity of triiodide, we can calculate out in the end the thiosulfate concentration. And if you want to then convert this to molarity, all you have to do is then divide by the volume of thiosulfate ion in liters that you have added to the solution. Right, so this part of the equation, right here, is just the same part that we just calculated here, and then you just multiply by 1 over the volume to calculate your concentration in the reaction. part 2. So once we've done that, right? So once we've done that, we have our known concentration of our thiosulfate solution. Now we can take this known thiosulfate concentration on to the next step to calculate the concentration of our bleach or the sodium hypochlorite. So we can see how in the next steps how we can do that, right? So part 2, we're going to have another series of reactions that are going to be used to determine the concentration of this bleach or the sodium hypochlorite solution. So first thing you need to recognize is that the solution that's being used of bleach is actually diluted 1 to 10. And you need to take that into consideration when you're looking at your calculations later. And this is going to be reacted with the potassium iodide in an acidic environment to provide the iodine that will then react with the sodium thiosulfate. So we'll see what that means here, right? So what we have is, again, another one of the iodometric reactions where the bleach solution is going to react with the iodide anion. It produces, under the acidic conditions, it produces iodine. And this iodine can then this iodine then goes on in the next step, and we're going to use it in the next step here. Oh, she's having internet troubles. Keeps kicking her off. Tell her this will be recorded so she can jump back on, and it should be available soon after. All right. So the second brownish iodine reaction is generated is going to be reduced to a colorless iodine solution following this reaction, right? So now the iodine, molecular iodine that we produce in the first step, we're going to react with the sodium thiosulfate to produce our iodide anions and the oxidized sulfur molecule here, right? And we're going to be using, again, Starch Indicator, because the Starch Indicator is able to visualize when the starch and the iodine react together. This has a blue color, right? So when we have starch with iodine, we're going to have a blue color, and then the starch with the iodide goes back to clear. So we would have been monitoring for a color change to determine when we've added enough of our sodium thiosulfate to the reaction mixture in order to, determine the concentration. And you can see again from both of these reactions, we have our equalities. We're then going to take these equalities and this step here, you see on the next slide, where we're going to do the same exact type of conversion, right? The concentration of the sodium hypochlorite that we want to determine, we're going to use the same conversion factors, right? Where we start off, we know this actually shouldn't be a number 1, right? This should be, we're going to have a known quantity, known number of moles of sodium thiosulfate. That's based on how much we're adding, right? So we have a known, quantity of sodium thiosulfate. We know from the the lower reaction here that we can interconvert between the concentration of iodine and the concentration of the thiosulfate. Oops, go down here. And we're going to plug that in here where we have 1 mole of iodine for every 2 moles of thiosulfate. And then we know from the first reaction that we can interconvert between the iodine and the perchlorate ion. Okay, go wrong way. And that's going to be the conversion factor here, right? As you can see, with our known quantity of thiosulfate, we can that cancels out units. The iodine gets canceled out as well, and we're left in the end with just the concentration of our bleach or a sodium hypochlorite solution. All right. Once we know the concentration of the hypochlorite ion from above and the molar mass of sodium hypochlorite, right? We have that here, 74.45 grams per mole. You can then calculate the mass of sodium hypochlorite that's in the diluted bleach, right? So this, all we do is we're just doing straightforward, right? We have the molar mass, multiply that by the number of moles, and that'll give us a number of grams. So this is, you know, Gen Chem 1 first semester stuff. Don't forget that in this experiment, we were only using 10 milliliters of that bleach solution because it was diluted 1 to 10. Because there was going to be, if you read through the procedure, you know, you only use 10 milliliters. So the concentration that you're determining here, or the mass that you're determining, is the mass based on a 10 milliliters of a bleach solution. So you're going to determine the mass of this, what you're determining is the mass of this bleach and 10 milliliters of the stock bleach. The procedure tells you you're going to be told the density. You're going to need the density here, right? So the density of bleach is 1.0121 grams per milliliter, with my really crooked line there, right? So you can see you have your density. It's just a little more dense than water. And then in order to figure out the mass of that 10 milliliters of stock bleach solution, you're just simply taking, right, the, you know, 10 milliliters, multiply that by the density here, and you can see that gives us 10.21 grams in that stock solution. And then to figure out the bleach concentration by mass, right, all we're going to do is, in the last step, this is the last step calculation they're asking you to go through, to get the mass of the bleach in that 10 milliliters of stock solution. You're going to be dividing it by the 10.21 grams, and then you're going to be multiplying that by 100% in order to, you know, determine what the bleach concentration is in percent, right? This is weight per weight percent. So it's going to be pretty straightforward, hopefully. All right. So what are we going to be doing here? Let me jump on over here. Let me open up my window. Give me 1 second. And this wrong one. All right. And I am here. All right. Let me share this window with you. All right. So in the lab module on Canvas, I have now posted the different, in addition to the pre-lab and the lab itself, this presentation has been posted there, but also in here is going to be, where's the submissions? Huh, something going on. Also part of the lab are these online data for each of the team numbers. So what I was going to do is, you know, assign one for each team. So why don't we just work down the line? Katie, Sean, you can do the online data team 1. Sophia, Jose, team 2, and I still didn't able to get back on. Kalina and Hannah, you could do team 3. So, and if you look at what is shown in here, and let me just pop onto that slide so I can show you what's in the data, which is right here. My computer is freezing up. computer just froze up. Let me try a different computer. Actually, let me see if I can pull the data up. I just got frozen. All right, let's see if this will work. All right. All right, so hopefully you can see this here. Can somebody post whether or not they can see what I just did there? Okay, you can see that. Great. All right, so what I just posted is data. So this is the team data for team 1. Right here you can see. So what we've given you is the mass of the periodate and the volume of the thiosulfate for part A. And then for part C, we gave you the volumes of the diluted sodium thiosulfate solution that was needed. So what you're going to do is, right, you can take your lab experimental report and you're going to essentially work through the calculations to fill in the other columns of the rest of the table here. So you're going to fill in the rest of the columns and then answer the questions at the end. And then I thought there were submission lines. I'm going to have to figure out what happened. I thought I had posted submission, the ability to submit the data online. I don't know why it wasn't popping up there, but I'll have an online submission for you there. So you just simply work through, calculate the data. I will be available and throughout this entire lab period to answer any of your questions that you do have during this time. So, and the goal is to do the lab report right now and submit it today, not for you to take your time. So that's the goal right now, is to submit. I'll be on available. My recommendation is, if you need to get in touch with me, just simply use the calls function. If you use the calls function in Teams, because it actually rings on my end. If you just simply type something to the chat, I might not see it right away. It doesn't pop up very well for me for whatever reason. So just give me a call and then we can connect and I can share desktops and we can answer any questions. Does anybody have any questions? We don't have a column for a volume of 10% bleach. Well, you should know it should be the same for all of them. What was the volume that we're using, Katie? It's the same for all of them. If you don't have the column, that's not a big deal, but you need it for the calculations. It's just 10 milliliters, right? Oh, it's at the top. There we go. The lab is due, right? We have 4:15 today is the lab period, 1:15 to 4:15. We only just talked for half an hour. I mean, most people had the lab done yesterday after not very much time. I mean, Wednesday after not very much time. So it shouldn't take you that long. Goal is just get it in, get it done, and get it submitted. Other questions? If there's no more questions, you can disconnect and go to Canvas, get your data. You have to do a conclusion. I think whatever the lab report asks you for, so just work through the lab report. I don't remember if there was a conclusion. I'd have to look. Oh, I don't have it open. My computer's completely frozen on the other side, so I can't see it handy right now. I'd have to go, let's see. Got two computers running here. So yeah, it says to include a results and discussion section. So it doesn't have to be, it shouldn't be that difficult, right? You're just basically discussing the results that you got in your tables and what was the goal. You know what the goal of the lab was, right? The goal of the lab is the title of the lab, is you're trying to determine the oxidizing capacity of the bleach. And, you're just going to go through and discuss it. Sources of error, yeah. Well, think about where the sources of error are. I mean, obviously it's in measurements. What types of measurements? Is it devices and things? Just print out the lab report, fill it out, and then submit it as a PDF. Yes, if you have a tablet, you could also just digitally write into the tablet or iPad and do the same exact thing. I'm okay with that, and then just save it. You don't even have to print anything out. Or if you want to, type information in PDF. If you have a touchscreen computers. Other questions? You can always get in contact with each other if you need to through the Teams function, right? So easy way to stay connected is just use Teams. All right. No more questions. You can disconnect. I'll stay off until the end, and then just give me a call if you have questions.